Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will continue into 4.4 hypothesis test for one population mean. Okay. As I mentioned before, untuk hypothesis testing, dia punya test yang terlibat sama seperti dalam topik estimation. Okay, yang mana first we will look into one population mean, and then we will look into the difference between two population means, okay, which is for independent and dependent sample. Then we have hypothesis test for one population variance and the ratio between two population variance. Okay, so firstly, let's look into hypothesis test for mean, okay, which is our first case for variance known. Okay. If you still remember at estimation topic, the first one, okay, the first estimation formula that we are look into for estimation for one population mean, specifically for if the variance of the population are known. Okay, so the assumption needed here is the population is normally distributed or the sample size is large. Okay, note. Firstly, you should know the population variance, okay? And then, when the sample size is large, then we will use this test statistic, which is Z equals to X bar minus mu naught over sigma over square root n. Okay, don't forget here the formula is sigma because we know the population variance. Okay, now look into example 4.3. The breaking strength of the population are normally distributed with standard deviation of 12. So the statement here referring to the known population standard deviation, which is equals to 12. And we have a sample of 11 bundle of wool fiber has a mean breaking strength of 436.5. Okay, so we have n equals to 11, sample of n equals to 11 that has mean breaking strength of 436.5. Okay, so standard deviation, this one is sigma, this one is n, and this one is x bar. Okay, mean of the sample of 11 bundle of wool. Okay, so the question is test at 5% level of significance whether the population mean is less than 445. Okay, so you are given the value of alpha. Alpha here is 5% level of significance. So this one is alpha. And then what we're going to test is whether the population mean is less than 445. Population mean less than 445. Okay, so I have stated that there are 5 steps that you should follow in order to conducting the hypothesis testing. So the first one, what should you construct is the H0 and H1, the null and alternative hypothesis. So what are our H0 and H1 here? So look at the last statement. What we want to test is whether the population mean is less than. Okay, so the keyword is less than. So our H0 is, so the first step is H0 mu equals to 445 versus our H1 mu less than 445. Okay, so saya letak notation kat sini, left tail. Okay, why? Because the sign is less than. So we will focus on left tail test. Okay, so that is the first step. Second step we have we need to decide on what are the test statistic that will be used. Okay, so saya guna notation TS lah. TS is referring to test statistic. Okay, tadi saya dah mention awal-awal sekali tadi, the test statistic is equals to Z equals to X bar minus mu naught over sigma over square root N. Okay, why we use Z here? Because we know the standard deviation of the population. You are given the value of standard deviation of the population. That's why we will use Z. Okay, so Z equals to X bar. So X bar is 436.5 minus mu naught. So mu naught here is this one. Yang awak tulis dekat hash naught tu, hash naught, H1 tu kan, berapa value yang kita test. So the test value is 445. So 436.5 minus 445 over sigma over square root N. So our sigma is 12 over square root N is square root 11. So finally we will get value of Z equals to negative 2.349. Okay, the third step, you have to find the critical value. Okay, critical value denoted by CV. So how to identify the value of the critical values? You should know first the value of alpha. So alpha here is equals to 0.05. Okay, so what you should look at the table number 4. Okay, table 4. So find the value of Z for alpha is 0.05. Okay, so look at the table 4. This one is the table 4. Okay, so find alpha 0.05. Okay, so alpha 0.05. Okay, you should look at this column. Okay, find 0.05. So 0.05 is 0.05. Okay, 0.05 is here. Z 0.05 is 1.6449. Okay, so let's say kalau soalan tu bagi value alpha is 0.01, so you just find value 0.01. 0.01 is here. So if Z alpha is 0.01 is equivalent to 2.3263. Okay, so for this case alpha is 0.05, so the critical value is 1.6449. Okay, you also can use table number 3, but I suggest that to use table 4 because you can get the value straight away instead of by looking at the table 3. Okay, so for this case our critical value is 1.6449. So you write the value is 1.6449. Okay, but don't forget to put negative sign here. Why? Because look at our H1. Tadi kita dah bagi tahu dah. Kita dah letak notation kat sini, dia adalah left tail test. Okay, so your critical value should be in negative value. So don't forget to put negative sign here. But if your test, if right tail test, okay, so the critical value should be positive. Okay, the other one is if your tail is if your test is two tail test, so the critical value should be plus minus value. Okay, number 4, step number 4. Step number 4 is the decision rule. Okay, step number 4 is decision rule. Okay, so how to write the decision rule? Okay, tadi kita dah identify value dia punya test statistic and the critical value. Then to construct the decision rule, you need to, okay, lagi nak senang tengok dia, kita tengok melalui you lukis dia punya identify the rejection region and the acceptance region. Okay, so saya lukis kat atas ni ya. So let's say this is the our region. Okay, to decide which one is rejection region and which one is the rejection region. Okay, since we are focused on left tail test, okay, so kita akan fokus dekat sebelah kiri lah. Okay, tadi kita dah dapat dah kita punya critical value adalah negative 1.6449. So let's say the value is here, negative 1.6449. Okay, so any value that falls or less than negative 1.6449, then we decide to reject, okay, the hypothesis, okay, by comparing the value lah. Okay, so this area is called rejection region, whereas this one is acceptance region. So we can write the decision rule as reject null hypothesis, reject hash not if test statistic less than critical value. So any value that falls in the rejection region here, okay, which mean that if the value is less than negative 1.6449, then we will decide to reject the null hypothesis. Okay, so step number 5 is decision and conclusion. Decision and conclusion. So what are our decision? Our decision is to reject hash not. Okay, reject hash not. Reject hash not since our test statistic, which is negative 2.349 less than negative 1.6449. So reject hash not since the test statistic less than negative 1.6449, meaning that our test statistic falls in the rejection region. Okay, so what are the conclusion that can be made here? Okay, so there is a significant evidence to conclude that the population mean is less than 445. Okay, tadi kita kata kita reject hash not. Okay, kita tak boleh nak accept hash not. So what are our conclusion? Kalau kita reject hash not, so our conclusion is the population mean is less than 445. Okay, so to write the conclusion, so the conclusion is there is a significant evidence to conclude that the population mean is less than 445. Okay, so keyword yang penting kat sini kena ada perkataan ni lah, significant evidence to conclude that the population mean is less than 445. Since we reject the null hypothesis tadi, so yang kita akan terima adalah our alternative hypothesis. Okay, now let's do example 4.4. The treatment time to treat patient using a new equipment is normally distributed with variance of 210.25. A sample of 9 patients has a mean treatment time of 26 minutes. Test at 2.5% whether the average treatment time of all patients is more than 25 minutes. Okay, so what are the information that we have in example 4.4? So kita ada value kat sini. Dia kata first value yang dia bagi adalah the treatment time to treat patient using a new equipment is normally distributed with variance of 210.25. So this one is sigma square. Sigma square. Why sigma? Because dia adalah referring to the population value, not the sample. Okay, then baru ada the word sample comes. A sample of 9 patients. So here is sample of 9 patients adalah our n. So our n equals to 9. Has a mean treatment time of 26 minutes. 26 minutes is our x bar. Okay, sample mean, which is the average treatment time for a sample of 9 patients. Okay, so the question is test at 2.5% whether the average treatment time of all patients is more than 25 minutes. Okay, so 2.5% here is our alpha. This one is alpha. And then the statement that we want to test is whether the average treatment time of all patients is more than 25 minutes. Ni keyword dia adalah more than. Okay, so the first step is you need to write the H0 and H1. So our H0 ataupun null hypothesis, our null hypothesis is mu equals to 25 versus H1 kita mu more than 25. Okay, so since the sign is more than, so more than kita akan test on right tail test. So the second step is write your test statistic value. Okay, number 2, calculate the test statistic value. So our test statistic here is we will use Z. Why? Because we know the population or variance of the population, which is 210.25. So Z equals to X bar minus X bar. Our X bar is 26. 26 minus mu naught. Our mu naught is 25. Okay, this is our mu naught. So 26 minus 25 over sigma over square root n. 210.25 over square root n. Our n is 9. Okay, but don't forget to square root also the value of variance. Okay, sebab yang diberi adalah value variance, bukannya standard deviation. So finally our Z value is 0.207. Okay, third step is find your critical value. So our critical value is Z 0.025. Okay, 2.5% is equals to 0.025. Okay, so since we are doing the right tail test, so you don't have to put the negative value to the critical value because we are doing the right tail test. So look at table 4. The value for Z 0.0025 is 1.96. Okay, this the value is here 1.96. So Z 0.025 is 1.96. Okay, step number 4. We want to decide the decision rule. Okay, so how to write the decision rule. Okay, kita lukis dulu dia punya rejection region and the acceptance region. Okay, So since we are doing the right tail test, so you are focused on the right side. Okay, so let's say this is the rejection region, which is the critical value is 1.96. Okay, tadi kita dah calculate value dia punya test statistik kita adalah 0.207. Okay, so the decision rule, first write the decision rule. The decision rule is reject hash not if test statistic greater than critical value, meaning that any value that falls in this rejection region, yang value area yang saya highlightkan ni, then we will reject the null hypothesis. Okay, ataupun dalam kata lain dia, kalau value our test statistic greater than the critical value, then we will reject the null hypothesis. That's why the decision rule saya tulis reject hash not if test statistic greater than critical value. Okay, so by looking at our rejection region, okay, we compare the test statistic and the critical value. So we can see that 0.207 does not fall in the rejection region. Okay, let's say 0.207 is here. Okay, 0.207. Okay, dia tak masuk dalam rejection region, then we are fail to reject the null hypothesis. So our step number 5, kita punya decision kita adalah do not reject hash not, since our test statistic is 0.207 is less than 1.96. Sebab tadi syarat dia, rules dia, kita reject hash not if test statistic greater than critical value. Tapi bila kita test, kita tengok kita punya test statistic 0.207 kurang daripada 1.96. That's why we do not reject the hash not. Okay, so what are the conclusion that can be right here? So we can write the conclusion as there is no significant evidence to conclude that the average treatment time of all patients is more than 25 minutes. There is no significant evidence to conclude that mu greater than 25 minutes. Ataupun tulis balik ayat yang kat atas tu. There is no significant evidence to conclude that the average treatment time of all patients is more than 25 minutes. Okay, so settle for case number 1, which is population variant or population standard deviation are known. Okay, case number 2, we have hypothesis test for mean, okay, but for variance not known and large sample. Okay, so population variant or population standard deviation does not known, but the sample size is large, which is greater or equals 30. So the assumption is the population is normally distributed, or the sample size is large, greater or equals 30, and the population standard deviation sigma is not known. Okay, of population variance. So the formula is the test statistic is equals to Z equals to X bar minus mu naught over S over square root N. Okay, look at example 4.5. A pharmaceutical manufacturer purchases a particular material from a supplier. The manufacturer select 30 shipments from the supplier and measure the percentage of impurities in the raw material from each shipment. The sample mean and variance are X bar equals to 1.89 and S square equals to 0.273. Test at 5% level of significance whether the average percentage of impurity is different from 1.8. Okay, so look at the information that we have here. So we have N equals to 30, number of supplier. The manufacturer select 30 shipment from the supplier. So N equals to 30. So this is our N. And then sample mean X bar we have 1.89 and S square equals to 0.273. So test at 5% level of significance. So our alpha is 5%. So this is our alpha. Whether the average percentage of impurity is different from 1.8. So untuk keyword different, symbol ataupun notation yang kita akan gunakan adalah not equal. Kalau more than, greater, less than, sign kita less lah. Okay, so step number 1, as usual, don't forget the 5 steps. So step number 1 is construct your H0 and H1. Okay, so your H0 since kita nak test on mean, so mu equals to 1.8 versus mu not equal 1.8. Sebab keyword dia different tadi kan. Okay, so this one since sign dia adalah not equal, so this is two-tailed test. Okay, yang kedua, calculate your test statistic value. So our test statistic value, formula dia adalah Z equals to X bar minus mu naught over S over square root N. So our X bar is 1.89 minus mu naught. Our mu naught is this value yang dekat awak punya H0 H1 tu. So 1.89 minus 1.8 over 0.273 over square root 30. Okay, ni ada square root. Kat atas ni pun square root juga sebab yang diberi adalah value variance. Okay, formula dia kat sini standard deviation. So the test statistic value is equal 0.943. Okay, yang ketiga, calculate your critical value. So our critical value is Z alpha. Our alpha is 0.05. Okay. Tadi kita dah define alpha kita 0.05. But since our sign kat sini adalah two-tailed test, so the alpha should be divided by 2. Okay, kalau sign dekat H1 awak tu adalah unequal, alpha kena bahagi 2. Okay, untuk one right tail or left tail, you don't have to divide the alpha by 2. But if your test is two-tailed test, then your alpha should divide by 2. So 0.05 divided by 2. 0.05 divided by 2, we get Z 0.025. Don't forget to put plus minus sign because this is two-tailed test. So again, refer your table 4. Okay, let's look into the table 4. Okay, table 4. Table 4. Oops. Z 0.025 is 1.96. This one, yeah. Z 0.025 is 1.96. So plus minus 1.96. Okay. Step number 4. We want to write the decision rule. Okay, so before we decide on the decision rule, kita lukis dulu dia punya acceptance and rejection region dia. Okay, since this is two-tailed test, so kita akan consider both right and left side. Okay, tadi value tadi kita dah buat. Sebelah kanan 1.96 lah. This one is negative 1.96. So, this is our rejection region. So, meaning that if your test statistic value falls either at left side or right side, so we will reject the null hypothesis. So, meaning that the decision rule will be right as reject hash not if reject hash not if test statistic less than negative CV or test statistic greater than critical value. So kalau ada two-tailed test, kita ada dua rules kat sini lah. Dia reject hash not if test statistic less than negative critical value or test statistic greater than critical value. So look at the region. So kita dapat value test statistik kita adalah 0.943. Let's say the value is here 0.943. Does not falls in the rejection region. Okay, maksudnya value dia tak jatuh dekat dalam rejection region kita. Maksudnya value our test statistic does not greater than 1.96, then we do not reject the null hypothesis. So our step number 5, do not reject hash not since 0.943 less than 1.96. So we can conclude there is no significant evidence to conclude that the average percentage of impurity is different from 1.8. Ulang balik ayat yang last tu. So there is no significant evidence to conclude that the average percentage of impurity is different from 1.8. So dia mesti memenuhi salah satulah, sama ada value tu kurang negatif 1.96 ataupun lebih 1.96. Tapi bila kita compare 0.943 dengan 1.96, value dia kurang. 0.943 less than 1.96. So that's why we fail to reject ataupun do not reject the null hypothesis. Okay, example 4.6. A construction company claimed that in order to construct a double-story house, the mean amount of cement needed to be used is 80 bags per house. Record taken from the management show that in constructing 40 double-story house, the mean amount of cement needed was 81 bags per house with standard deviation of 3 bags. Assume that the amount of cement is normally distributed at 2% level of significance. Is there enough evidence to support the company claims? Okay, what are the company claims? Company claims is mean amount of cement needed to be used is 80 bags per house. Okay, so this is the claims. So next we have another information. The mean amount of cement needed was 81 bags per house with standard deviation of 3 bags. Okay, the sample dia ambil adalah 40 double story house. So our n is 40. N equals to 40. X bar equals to 81. And standard deviation S equals to 3. Okay. Now we want to test at 2% level of significance. So 2% level of significance is our alpha. So alpha equals to 2%. So let's write the H0 and H1. Okay, step number 1. So still we want to test on mean. So mu equals to 80 versus mu does not equal 80. Dia tak kata more, dia tak kata less, kan? So kita decide our alternative hypothesis is not equal. So not equal, this one is two-tailed test. Jangan lupa sebab nanti kenapa nak tulis either is left tail ke right tail or two tail. First kita nak decide nanti kita punya rejection region tu belah mana. Dan satu lagi, kalau two tail, alpha kena bahagi 2. Kalau awak tersilap pada dia punya H1, so it will affect your the next step lah. Okay. So yang first kena betul dia punya H0, H1 dia, sama ada left tail, right tail or two tail test. Okay, step yang kedua adalah calculate the test statistic. Okay, so this is case number 2. We still using Z. So Z equals to X bar minus mu naught. Our X bar is 81 minus 80 over S over square root N. 3 over square root 40. So Z will be equal to 2.108. Okay. Step yang ketiga, calculate the critical value. So critical value, okay, since we are using Z, so Z alpha kita adalah alpha 0.02, but we need to divide by 2 because this is two-tailed test. So Z 0.02 divided by 2, we get Z 0.01. Don't forget plus minus sign. So meaning that Z 0.01 is equal Z 0.01 is here, 2.3263. So plus minus 2.3263. 3263. Okay, now we want to write the decision rule. Okay, before that kita lukis dulu dia punya region. Kita buat kat atas. Okay. So dia adalah two-tailed test. So kita punya rejection region kita sebelah kiri dengan kanan lah. So this one is 2.3263. This one is negative 2.3263. So our decision rule is we will reject H0 if test statistic less than negative 2.3263 or test statistic greater than 2.3263. So ada dua lah sebab dia two-tailed test. Reject H0 if test statistic less than negative CV or test statistic greater than critical value. Okay, now we compare the value of test statistic dengan critical value. Tadi kita dapat kita punya test statistic is 2.108. Let's say the value is here 2.108. Dia tak masuk pun dekat dalam rejection region kita. Rejection region kita this one yang saya lorikkan ni. Okay, so it fall in the accepted region. So meaning that we fail to reject hash not. So our step number 5, if our decision do not reject hash not, since tulis balik 2.108 is less than 2.3263. So there is no significant evidence. There is no significant evidence to conclude to conclude the mean amount of cement needed to be used is different from 80 bags per house. Ataupun boleh buat there is significant evidence to conclude that the mean amount of cement needed to be used is 80 bags per house. Sebab tadi kita accept, kita tak reject hash not. Maksudnya average amount of cement needed is equals to 80 bags. Sebab kita fail, do not reject hash not, so kita accept hash not lah. So meaning that the average cement needed equals to 80 bags. Okay, look at example 4.7. An administrator at local hospital state that on weekend the average waiting time for emergency room visit is 10 minutes. From our random sample of 40 patients, the average waiting time for these 40 patients was 11 minutes with a standard deviation of 3 minutes. So you are given the Minitab output. So look at the output. So you can see the value of n here. N equals to 40, mean equals to 11. Standard error of mean 0.4743. So this is, you can get this value by cari the punya standard deviation. Standard deviation equals to 3 divide by square root n, 3 over square root 40. So let's say soalan bagi dia kosongkan value standard error mean ni, dia suruh awak calculate, letak X kat sini. So nak dapat value standard error mean, awak boleh calculate dengan cara standard deviation divide by square root n, 3 over square root 40. So you will get the value of standard error mean 0.4743. You're also given the value of confidence interval, and then we have value Z here. So Z is the test statistic value 2.11 and also the P value 0.035. Okay, so from the Minitab output given, test at 5% level of significance that the average waiting time is different from 10 minutes. Okay, so yang ni cara dia lain sikit sebab kita tak gunakan value, we does not compare the value of test statistic and the critical value, but we will use the P value. Okay, cuma step dia sama. We have 5 step. So kita buat step yang pertama dulu lah. Step yang pertama adalah write the hash not and h1. So our hash not and h1 here is, okay, ayat dekat sini dia suruh test at 5% level of significance whether the average waiting time is different from 10 minutes. So meaning that hash not kita mu equals to 10 versus mu does not equal 10 minutes. Okay, so this is two-tailed test. Okay, step yang kedua. Okay, since kita ada value P value, so the test statistic value will be replaced with the P value. So kita akan menggunakan P value approach. So our test statistic kita adalah P value. So P value equals to 0.035. Okay, yang ketiga. Okay, kalau kita guna P value, kita akan compare dengan value alpha lah. So alpha will be our critical value. So our alpha equals to, kat sini dia kata test at 5% level of significance. So alpha equals to 0.05. Okay, tak perlu bahagi 2. Terus ambil sahaja berapa dia suruh test dekat level of significance berapa. Okay, yang keempat, so decision rule untuk kalau menggunakan p-value approach, rules dia satu je. Okay, reject hash not if p-value less than alpha. Okay, dia punya rule ni satu ni saja. Kalau guna p-value, ingat kita akan reject hash not if p-value less than alpha. Okay, so you just compare p-value dengan alpha. So our decision here, set yang kelima, since p-value is 0.035 is less than 0.05, so we reject hash not. Since 0.035 is less than 0.05, then we reject hash not. So what can we conclude here? We can conclude here that the average waiting time is different from 10 minutes. Kita tak accept hash not kan? Kita reject dia. So yang kita accept adalah H1. So meaning that we can say that the average waiting time is different from 10 minutes. There is significant evidence. There is a significant evidence to conclude that the average waiting time is different from 10 minutes. Okay, let's continue into case number 3, hypothesis test for mean, which is variance not known and small sample. Okay, the first two cases, we have a variance known and then we have variance unknown but large sample size. Okay, but for the third one, we does not know the variance or standard deviation of the population value, and then the other one is the sample size is small, which is less than 30. Okay, so the assumption are the population is normally distributed and the sample size is small and less than 30, and the population standard deviation sigma is not known. Okay, we highlight here variance not known and small sample size. So what we want to test here is again still on value of mean, mu. So our H naught is mu equals to mu naught. Our H1 alternative either mu less than mu naught or mu greater than mu naught or mu does not equal mu naught. So the test statistic here, we will use T. Okay, T equals to x bar minus mu naught over S over square root N. Okay, untuk kes pertama dan kedua, dia tak akan jawapan tak salah lah kalau awak buat tertukar antara kes number 1 and number 2, sebab yang membezakan dia kat bawah sahaja sama value S dengan sigma. Okay, tapi untuk kes nombor 3 ni dia akan, kalau tersilap memang salah semualah, terus sebab test yang digunakan adalah T berbanding kes number 1 and number 2 kita guna Z. Okay, so look at example 4.8. The breaking strength of 11 bundles of wool fiber have a sample mean 436.5 and sample standard deviation of 11.9. Assume that the breaking strength of the population are normally distributed. test at 5% level of significance whether the population mean is less than 445. Okay, so we have information on n here. N equals to 11. And then the sample mean is x bar. So this is the x bar value. And this one is sample standard deviation. So this one is S. This one is N. Assume the breaking strength normally distributed. Test at 5% level of significance. So this is our alpha. Alpha equals to 5% or 0.05. So we want to test whether the population mean is less than 445. So this will be our hypothesis lah. Population mean less than 445. So H0 and H1, our first step is H0 mu equals to 445 versus mu less than 445. So this one is left tail. Second step, calculate your test statistic. So our test statistic is T. T equals to x bar minus mu naught. 436.5 minus 445. Again, our mu naught is here. So kadang-kadang student akan dia terbalik. Dia buat 445 tolak 436.5. So make sure awak tulis benda yang betul lah. X bar minus mu naught over S over square root N. Over 11.9 over square root N. Our N is 11. So we will get T equals to negative 2.37. So yang ketiga, find your critical value. So our critical value for case number 3, we use T. Okay, T, so alpha is 0.05. So what you need to find is T 0.05, degree of freedom n minus 1. 11 minus 1 is 10. But don't forget to put negative sign because we are using left tail test. So you should put negative value here. So meaning that your T will be equivalent to negative. So T 0.05, degree of freedom 10, we get 1.812. 1.812. This one. Okay. 1.812. Okay, tak perlu bahagi dua alpha dia sebab kita punya test kita adalah left tail test. So alpha tak perlu bahagi dua. So kita lukis dia punya region dia untuk decide what are the decision rule. Okay, so this is left tail test. Okay. So the critical value is negative 1.812. So any value that falls in this rejection region, so kita akan reject lah. Ataupun dia punya rules dia adalah, okay, yang keempat, step yang keempat, write the decision rule. So our decision rule, reject H0 if test statistic less than negative critical value. Okay, so kita akan reject H0 if test statistic less than negative 1.812. Okay, so kita pun let's circle into the region. Okay, negative 2.37 falls in the rejection region. Masuk dekat sini. So let's say negative 2.37 is here. Negative 2.37 falls in the rejection region. So we decide that to reject the null hypothesis. Okay. So number 5, we reject H0 since negative 2.37 is less than negative 1.812. So what can we conclude here? So we can conclude that there is a significant evidence to conclude that the population mean is less than 445. Okay, kita reject H0, kita tak terima H0, tapi yang kita terima adalah H1. So meaning that there is a significant evidence to conclude that the population mean is less than 445. Okay, example 4.9. The following data are the impurity level in the steel alloy from an analytical test. Assume that the impurity level has a normal distribution using alpha equals to 0.01. Is there enough evidence to conclude that the mean impurity level is more than 2? So if you are given the raw data like this, first you need to calculate the value of x bar and standard deviation first. So by using your calculator, you will get x bar equals to 2.325. X bar equals to 2.325 and standard deviation S equals to 0.2252. Okay, now we can conduct the hypothesis testing. Okay, alpha is 0.01. So apa yang kita nak test? Kita nak test mean impurity level is more than 2. So first step, our H0 mu equals to 2 versus H1 mu more than 2. So this one is right tail. Right tail. Okay, yang kedua, calculate your test statistic. So our test statistic is T because we does not know the population variant or population standard deviation and our n is small. We only have 8 sample size here. So test statistic is T equals to x bar 2.325 minus mu naught. Our mu naught is 2 over S over square root n. 0.2252 over square root 8. So finally we get T equals to 4.082. 4.082. Okay, step number 3. Find the critical value. So our critical value is T alpha. So alpha no need to divide by 2 because we are using right tail test. So T alpha 0.01 and minus 1 degree of freedom. 8 minus 1 is 7. So look at T table. Find the value of T alpha 0.01. 0.01 with n minus 1 degree of freedom 7. So we get alpha 0.01 0.017. So the critical value is 2.998. 2.998. Okay. Now we want to write the decision rule. So how to write the decision rule? We reject H0 if test statistic greater than critical value, because if we kita buat dia punya lukisan dia, rejection region dia, kita nak tengok sebelah kanan. So this one, this is the rejection region. Critical value dia adalah 2.998. Okay, so we will reject H0 if test statistics greater than 2.998. Okay, so since we get test statistic is 4.082, which is greater than 2.998, so we will reject the H naught. So our decision, step number 5, reject H naught since 4.082 is greater than 2.998. So there is a significant evidence to conclude that the mean impurity level is more than 2. There is significant evidence to conclude that the mean impurity level is more than 2. Ikut balik ayat dari soalan tu. So untuk okay, now please complete example 4.10, 4.11. Tiga example ni tolong siapkan dan submit dalam Google Classroom. 4.10, 4.11 and also 4.12. Okay, and lastly 4.12. Okay, this one yang saya nak summarisekan lah untuk hypothesis testing for single mean yang kita baru belajar tadi. Kita ada 3 cases. Case yang pertama, hypothesis test for single mean, variance or standard deviation of the population unknown. Okay, so boleh tengok kat sini saya dah buat dalam bentuk table. Kita ada left tail test, right tail test and two tail test. So macam mana nak tulis dia punya H0 and H1. H0 biasanya sama untuk ketiga-tiga test. Okay, yang berbeza adalah untuk H1 lah, sama ada left tail, right tail or two tail. And then dia punya test statistik yang kedua adalah test statistik. Okay, test statistik, this one untuk case yang pertama, ini adalah untuk case yang kedua. So kalau boleh tengok kat sini, beza dia sama, dua-dua guna Z. Cuma untuk case yang pertama, this one is sigma. Untuk case yang kedua, dia adalah S. Okay. Dan step yang ketiga, kita ada critical value. Okay, untuk left tail, don't forget to put negative sign on your critical value. So dia punya critical value adalah negative Z alpha. Untuk right tail, just Z alpha. But for two tail, you need to divide the alpha by 2. Okay, alpha bahagi 2, and then don't forget to put plus and minus sign because we will consider right side and the left side for the rejection region. So this is the decision rule. Okay, untuk left tail, reject H0 if test statistic less than negative critical value. This one, reject H0 if test statistic greater than critical value. Dan untuk two tail dia ada 2, reject H0 if test statistic less than negative critical value or test statistic greater than critical value, or otherwise you can use p-value. P-value dia punya rules dia satu je, reject H0 if p-value less than or equal alpha, and then make your decision and conclusion. So same goes to case number 2, but case number 2 is for variance unknown, and then sample size is large, greater or equals 30. Okay, and then for case number 3 is specifically for variance unknown but n less than 30. That's why we will use T. Okay, so boleh tengok kat sini dia punya summarize. Untuk left tail, right tail and two tail, their alternative hypothesis. And then the test statistic, we use T equals to x bar minus mu naught over S over square root n. And then the critical value for left tail, right tail and two tail. For two tail, don't forget again to divide alpha by 2 and put plus minus sign. Okay, so this is your decision rule untuk setiap test lah, left tail, right tail and two tail. So choose guna yang bersesuaian lah. sama ada left tail, right tail or two tail. Cuma kena hati-hati bila two tail, mesti bahagi alpha dengan 2. Alpha divided by 2. Okay, and then if you use p value, rules dia satu sahaja, reject hash not if p value less than alpha. Okay, thank you.